All right, welcome everyone. Uh, Let me see. We have okay. I can see just two people, Precious and our cult. Oh, nice to meet you guys. Yeah, hello. I think we'll just have to wait a bit for others to join. Then we can then continue. So while we are waiting, in our last class, I think we went through some CNN. We saw how it looks like in terms of the images. Then we talked about the different layers, the convolutional layers, where we said it's the input layer of the model. Okay. Then we talked about the pooling layers, and we said that the pooling layers are used to, it's like summarizing a paragraph by picking out the most important sentence. So it takes the largest value from the groups of pixels. We talked about the fully connected layers, and we say that it's similar to how, after observing those different aspects of the object, you combine all of them to identify it. Then we talked about the activation functions. We saw different common CNN architectures, the LeNet, AlexNet, ResNet. Then we did some practical example. So today we're actually going to be looking at something more practical. We are going to be using some pre-trained models to to predict some images, and we're going to be downloading the images from the internet. And yeah, we'll see how it works. Okay, so let me just share my screen so that we can just go through it. I can see Victor, I can see Ade, Abimbola, welcome. Okay, can you all see my screen?
Yes.
All right. Okay, so today we are going to be looking at large scale image recognition architectures and object detection, right? So, I mean, so far in our previous three classes, it has revolved around knowing how to bring a data set, then bring in your model, that's your Keras model, then we train it using the data set, and then we do some predictions. So that's what we've been doing for the past 3 days, though in different aspects. And I think the second day we saw some optimization and regularization method. So today it's going to be less of training and more of using models that has already been trained, right? Because yeah, it's good to know how it works, which was why we started that. So you know how these models are being trained and how you can train your own model. But then again, if maybe you want to save time, you can actually pick up a model that has already been trained and then use it maybe in your application, right? Let's say tomorrow you want to start up a company and maybe you want to put in, you want to have a section of the company where it can detect the images from the users, right? So you may not have that luxury of time to start training because you will need enough data to train your model. So instead of passing all through that process, you can actually just pick up a model that has already been trained and then use it on your data. So yeah, today we're going to be seeing more of that. So let's go through some slides as usual. So yeah, we are going to be diving into large scale image recognition and object detection, and we are going to explore some advanced CNN detections and learn how to detect and classify multiple objects. Okay, the next slide, introduction So large-scale image recognition is all about teaching computers to recognize and categorize thousands of different objects in images. These technologies power applications like image search engines, and I'm sure you've seen that of Google before. You can search images on Google and to bring out similar images. Social media, photo tagging, and more. For instance, when you upload a photo to Facebook and it suggests tags for your friends, that's image recognition at work. And we are going to explore models that make this possible. So we have advanced scaling architectures. We have the Inception, just created by Google. It uses a novel approach called inception models, which allows the network to look at the same input with different filter sizes simultaneously. Then we have the exception and extension of inception using depth-wise separable convolutions to make the model more efficient. Then we have the mobile net, optimized for mobile and embedded vision application, balancing performance and efficiency. Right, so you obviously you can integrate it into your mobile phone. Then we have efficient net, known for its ability to balance accuracy and computational cost by scaling the model. It systematically scales depth and resolution to find the best combination. So each of these architectures builds on basic CNN principles, but introduces information to improve performance and efficiency. Then we have the object detection application. So object detection is about recognizing objects and their location, unlike image classification, which only tells us what is in the image. Object detection also provides coordinates for each object. This is crucial for applications such as self-driving cars, like detecting obstacles, like G's, traffic signs, and obstacles. Also use it in security system, monitoring and identifying suspicious activities. The image as the medical aspects used in detecting tumors, fractures, or other abnormalities in medical scans. So the ability to locate and classify objects in real time makes object detection a powerful tool in many fields. Then we have the multi-object classification. So multi-object classification involves identifying and classifying multiple objects in a single. This is important for understanding complex scenes, such as a busy street with cars, people, and vehicles. There are models that can use that environment. Let's say you take a picture of the street. There are a lot of things, cars, dog, people standing, dogs, cats, all of that stuff. So yeah, this is where the multi-object classification comes from. So, from this particular coordinates to this coordinates, it's a cat. It will just draw a square around it. Then to pick out the round and say this is a car, all this kind of so that it's able to detect multiple objects in a single image. So each object is recognized separately and its location is noted. So for example, in a photo of a living room, the system can detect and classify the couch, table, television, and so on, providing a detailed understanding of the scene. Okay, localization techniques. So to detect objects, we need to know where they are in the image. Localization techniques helps us predict the coordinates of the bounding box that surrounds each object, sliding window, the region proposal, the anchor box. So these are just terms associated with localization techniques. So that sliding window it involves moving a small window across the image and classifying each section. While straightforward, it can be computationally expensive. Region proposal. It generates potential bounding boxes, region of interest, and then classifies them. It's more efficient than sliding window. Anchor boxes. These are predefined boxes used during training to predict objects. They help the model learn to detect objects of various size and aspect ratios. So all these techniques are foundational in many object detection algorithms. Then we have a common object detection algorithm. So there are several key algorithms, and there are several algorithms that have been developed for object detection. Its own strengths. We have the RCNN, region-based convolutional neural network. It uses region proposal to detect objects. And I think in our last slide we saw the region proposal. So it's a method that generates potential boundary boxes and then classify them. So we have the RCNN. It's accurate but can be slow because each proposal is processed independently. Then we have the fast RCNN, which is an improved version of the previous one that shares computation across proposal, making it faster. Then we have the faster RCNN. So this one works more efficiently and significantly speeding up the process. Then we have the YOLO, you only look once. This treats detection as a single regression problem, making it very fast and suitable for real-time application. We have the SSD, single shot multi-box detector, uses multiple scales to detect objects, balancing speed and accuracy. So all these algorithms have made significant strides in making object detection both fast and accurate. So these are different algorithms that we have out there. Right? So maybe if you want to use any of them, you just need to go online, see how you can pick them up and start applying them. So we're going to see a few of them today. All right, so we all know the normal process when it comes to machine learning, data preparation, as annotating images. This image is unlike normal regression and, will I say, the usual scikit-learn libraries, right? So data preparation, annotating images with bounding boxes and class labels. This means drawing rectangles around objects and images and labeling them. So that is you preparing it. Okay. So we have the model training. Using this annotated data to train a model. The model learns to predict bounding boxes and class labels from the training data. Then we have evaluation. Obviously, you need to evaluate the model to know how it's performing. So assessing the model's performance using metrics like mean, average, precision, which measures those the models. So all this process ensures that a model can accurately detect and classify objects in new images. So this is just the process one is going to take in order to do object detection. You need to gather as much data as you can, start cycling them. Oh, this is a dog, this is a cat, which can obviously be stressful at some point. But that's how it needs to be in order for you to train that model effectively. Then we have the real world application and challenges. So object detection has numerous real world applications, autonomous vehicle detecting, like we talked about it earlier, detecting pedestrians, vehicles and road signs to navigate safely. We have the security systems monitoring for suspicious activities and identifying intruders. We have the medical imaging used to identify different kinds of tumors, platforms, and other anomalies. Then, however, there are other challenges that are associated with this. Like I mentioned, data annotation. It requires extensive manual effort to label large datasets. Yeah. Then we have model complexity. That is balancing accuracy and computational efficiency can be challenging. Right. Then generalization, ensuring the model performs well on diverse datasets is crucial for real-world application. So these are some of the challenges we are likely going to encounter. So overcoming these challenges is key to building It's key to building successful object detection system. All right, so implementation. Okay, actually, we're going to be using um some some of the pre-trained models for detection. Not too much work, but basically just to download images and see how to use some of this pre-trained model. I think, yeah, this is the last slide, so I'll be moving over to the notebook. I don't know if anyone has any question yet. There's no question in the chat box. Okay, if you have any question, please just let me know. All right, let's move on to the notebook. Can you guys see my notebook? Is my notebook visible?
Yes,
Yes,
we
but
can
you
see.
can zoom it a bit.
Oh, okay. All right, cool. So, as usual, we are bringing in some libraries we need. All right. Then in this is actually where we bring in the pre-trained model. We are bringing in the mobile net V2, right? So that's where we are bringing it in. So this is where we load our libraries and a pre-trained model. So we are using the model V2 model, which is pre-trained on the ImageNet dataset, and it can recognize 1,000 different object categories. All right, so yeah, this is how you load it in. Then, no, I'm not connected yet. Let me connect. Uh, let's click on this. I need to mount my drive. So, we're going to be working with external images, and though I've downloaded some, or we can still download. What is that? Oh, okay. I think I may be connected on the other side. That's why. Yeah. Okay. Should be able to connect now. Okay. It's coming up. All right. Let me just mount my drive. All right. It's in. Okay. Cool. So, let me close this. All right. So this is where we load and pre-process the data sets. So we load the image from my drive. I'm loading it from my drive rather. So if you're using this network, you just need to replace this with the path to your image. All right. So here we are resizing it to fit the model we are trying to use. Then the image is converted to an array, expanded to match the input shape expected by the model. So this is where we are expanding it. Okay. Give me a sec. Um, okay. So we expand it to fit the model we are trying to work with, and then we process the image array. Remember, this process is coming from the pre-trained model. Then after we've load, I think sorry, I need to run this. Sorry, I need to run this. Okay, I need to run this too. All right, I need to process data. So this is where you do the prediction. Again, I brought in an external image from my drive. It's here. It's an image I downloaded. I'm still going to download some for us to see. Then do the whole processing and everything. Then this is where we are doing the prediction. So we're using the model to predict that image array. Then we use the decoded predictions to decode and then predict the top, sorry, bring out the top three image that is close to what it's predicting. And this is where I visualize and then print out the results. So this is the elephant I actually passed in. And then this is the top three predictions based on the score. So right now it's classifying this as African elephant. Then these other ones are just lower score. I think I should just bring in another one from the internet. Okay, okay. Let me download this one. Give me a sec. Okay, I need to upload it. Okay, elephant. So, okay, I've uploaded it. Now let's make use of that one I just downloaded. I'm going to refresh this. Okay, here it is. So I think I'll just have to put in number two here because the file path is the same. I'll just put in two here. I'll pre-process it again and yeah, do the prediction. Okay, so let's see let me run it in a different cell. This is for the first one. Let's see what it's going to say. So yeah, it had to resize it to fit the image. Again, it's classifying it as African elephant. The Indian elephant took a higher score. So generally, this is just how you can use a pre-trained model, right? Right. Depending on your infrastructure, you just need to make use of know how to do the setup and how to implement it maybe on the front end, so that whatever your customer or your user is passing it in, it can easily just bring out maybe the top first prediction. So that's just one. Then I have another one here. This one is it's a dog. Okay, so let me load down, process it. So this is it. It was able to classify this dog as a golden retriever. 91% accuracy. Right. So another example I have you quickly download that so that we all see. I'm going to bring the file parts. Let's see what it's going to say. Um, let me pick this one. Okay, I've downloaded it. Let me upload it. Okay. Yeah, it's up. It should be reflecting here. Let me refresh. It's not reflecting. Oh, it's here. Okay, it's here. All right, so I'm just going to repeat the part and then replace it with this. So I'm going to run that. So it's just the same process. Now, don't mind the fact that I'm actually repeating this, right? In as much as we are learning, but to be more professional, what you can actually do is to turn this stuff into a function, right? Because it's the same code that we are repeating all over again, right? Since it's one single model we are using and the size it takes in is always going to be this shape. And what is only changing is this. You can just turn it into a function such that only what it takes in, the parameter it takes in is the image. So it will also help reduce the whole repetition of code. So it's called code refactoring. So that's what you on the other end can do, right? But I just had to do this one because we actually do. But then it's the same process for all. Comes in, you change the size to fit what the models accept. Then you turn it into an array, expand it to fit, then pre-process it, does the prediction, decodes the prediction, then brings out the top three classification based on the score. So let me run the one for cats now. Did I? I think I did. So it's classifying it as tabby. Is tabby a cat? I don't know why it's classifying it as tabby. Let's find out. I don't know. I'm not familiar with cats, but it looks like tabby is the name of a cat. Don't mind me. I'm not too conversant with cat, but as you can see, it's obvious that tabby is the name of it. Or probably a class of cats. See. Okay, a tabby cat. So it's actually a classification of a cat. So it was able to predict that with a 57%, 59% accuracy, or approximately 60% accuracy. So yeah, I could go on and on and on. I think I'll just leave you guys to explore the car on your own, explore the flower on your own too. Yeah, you can do those two on your own. All you need to do is just depending on where you're running the code from, maybe your local environment or from Google Colab. All you need to do is just change the file path to the image file path to yours. So for you can try it for car and you can try it for flower. So what we have here is us using another model, another pre-trained model. Remember we talked about inception. So this is how you bring in your inception model, right? This is how you load it in. It's just similar to the mobile nets we saw above. So here I am using it to classify a bird. I have a bird already downloaded. So I'm just going to run this. There's actually a parrot. Okay. So yeah, this is what it's classifying it as. So another thing you can do is to pick this out and maybe go and research if it's actually true. Because when I went to pick that image, it was actually showing me that that is a parrot. But yeah, we see that it's this. Let's look for another bird image. Maybe we should go for an eagle. Let's see if it's able to detect an eagle. Let's pick out an eagle. So let's see how smart this model is. You know what? Let's try it with this one that there is a human being. Let's see how smart this model can be. So I'm trying to download this one. This is one I'm downloading. So let's see if this model will be able to detect an eagle from it. It's not good. Oh, sorry, my network is on a bit. Okay, it's coming up. I'm going to download this. So I've downloaded that. I'm going to upload it now. All right, so let's see. Oh, sorry. Let's see. Eagle. Okay, so let me copy the parts. I'm going to fix. Sorry, I'm going to duplicate this. Then I'm going to paste the parts of the eagle here. So remember that ego has a person in it. So let's see if it will be able to detect. Let's see what it's going to print out for us as a result. Okay, are you seeing? So it's able to detect the ego with a 85% accuracy. So you can see that this model is actually, it's smart enough to know that there is an ego here, right? Despite the fact that there's another object in it, it's able to detect an ego. So yeah, so this is just me using an inception model, right? This is just how you load it in, and it's the same format, same process. What I have below is another model, ResNet. So I load the model, then I'm going to use it on a bicycle. I don't have a bicycle, so let me go and download it. Which one will I take? Uh, which one should I pick? Someone should choose. Hello, someone should choose the one I should go with.
Let's go with the red one.
Which one?
Yes.
Okay, so I'm downloading it now. Okay, I'm going to load it, upload it. Okay, so it should reflect here anytime soon. All right, here it is. So I'm going to copy the parts and I'm just going to fix it inside here. I'm going to run that. So again, it's resize it. Hey, I forgot to point out, just so you know, yeah, each model has the size of it takes in, the height and width it takes in. So we saw that for mobile nets, it takes in 244. Yeah, sorry, 224. So that's why we are just putting all these parameters, right? Then for Inception, it takes in image size of 299. So whatever the size, just so you know, the size of those images varies. Don't know if you noticed. Uh, Let me check the properties, file information, because it's not showing the size. It's not. But yeah, the size are actually different. Yeah, the file are actually different. Let's see the bicycle. Look at the bicycle. Just hovering on it should this should show me. It's not showing me. Okay, so here is the size actually. I believe you guys can see this. Yeah, you guys can see it. Okay. Uh, so this is the size. So it's just going to reshape this to that 299 to fit in. So for inception, it takes in 299. That's why after predicting it, this is what that image looks like. Right. So now for this REST net we are about to use, it takes in 244, similar to the mobile nets, or it's the same like the mobile net. So let's run this. Whoa, it is not that the score is not that high, right? Then another thing I want to let also advise we do when we are picking out this model is to probably check what the model is good at, right? What the model is good at. Because look at right now, it's this bicycle, its scores are very low, and I'm not even sure this is the name of a bicycle. Let me try it with this resonate. Okay, just resonate we just did. Let me try it with this guy, this inception. Let's see what Inception is going to predict for us.
Mm-mm.
So you may also want to research about what somebody is typing on my screen. Who is typing on my screen? Somebody is typing on my screen. Oh, uh, that should be annotation. Okay, I may not have time to. Let me see if I can delete it. Please give me a sec. Let me clean this off. Okay. The person is exploring room. Interesting. Okay. That's fine. All right. So I want to try that same bicycle with another model. Let's see. So I was trying to say that whenever you're trying to use a pre-trained model, right, you need to know what it has been trained on. If not, you end up using a model that is not you're not supposed to use for that particular classification or detection. So right now I'm using it on Inception. Let's see what Inception will print out for us. Are you seeing? Are you seeing? So sorry, Inception was able to predict this as a mountain bike with an with 86% accuracy compared to when we used ResNet to predict that same image. You saw the accuracy we got. Very, very low. And I don't even think this is the name of a bike, right? So what we can actually do is maybe just pick this out. What can you use ResNet to use it classify, and then you know where to apply it. So that's just another thing I wanted to point out to us. So let's try something else. Let's try something else. What can we? Oh, what is in my mind now? Let's try the book. Mm, no, mm, no, like it's no. Okay, let me work with this. So I want to try a book, and let's see if the ResNet model will be able to text that accurately. The Bible. Okay. Whoa. What's wrong with this ResNet? It keeps predicting nematode matchstick. What's this nematode self? Because me, I don't know. Let me check what nematode is. Maybe it will give us an insight into what it is for predicting. Whoa, organisms. So if ResNet is crazy enough to detect a book as nematode, it means that it can go probably beyond this environment, maybe this industry. So let's look for something similar to this. Will I call it biology? Well, what will I look for now? Because this thing are disgusting. Yeah, bacteria stuff are not looking nice. Let me look for guys. I'm not too familiar with biological stuff, so if you're familiar with, if you have anything in mind, you can mention it so I can just go with it. Any suggestion? Any suggestion? Let me see if it's able to detect this. Warm. Okay. Let's see what ResNet will do for us this time around. Right click, upload, upload the worm. Let's see this ResNet that is killing PD. I'll try that too. This ResNet that does not want to go out beyond the biology industry. Let's see what it will do when I give it a worm. You better predict this one well. Oh. Better predict it accurately. Hey, wahala. Okay. For some reason, it's still giving us nematode. And no. Okay, let me try the millipede. We'll go with that one then. If it's not giving us something similar, we're just going to overlook it. Millipede. Let's see. Gosh, this does crazy. Oh, this is a JPEG. I think it takes in 7 images. Millipede. Okay, I'm going to upload it now. Okay, so we should be saying it here. Millipede, 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 millipede. What's taking you so long? Millipede. Ah, fresh again. What's going on? Okay, it's still invisible now. What's wrong with it's here now. Okay, please allow me to refresh this now. Maybe the models use virus identification. Okay. I mean something we can experiment in as much as we don't have much time. I'll leave that for you to explore. Okay, here it is finally. Copy the path, place this. I'm going to change this. Mm, ah. Okay, so I think not like I don't know what I'm supposed to do, right? It's just to come here and say what you can use ResNet for. I mean, everybody knows that. Everyone knows that's just what we'll probably just do. Not image, rather search. Not see anything reasonable. Okay, so our time is already running, so I'll just leave you guys to research on that. Right? It's interesting that despite all what we are passing in, it's not giving us a good accuracy. Okay, so what I'm going to do, I'm going to go and look for a matchstick since it looks like that's what it's saying. Sorry, we are learning, so we are just trying to see what works for that resonance. Let's do this. matchstick. So this will be the last one before we go to the other model. Okay. So let's see what it's going to say this time around. Now that we've given it what it's predicted. I mean, we obviously gave it a name. Okay, we didn't give it a name at it. So let's see what it's going to do. So yeah, it's fun when you have the model already. So like I said, you just need to know what it can predict accurately, right? What it was trained on. So you don't end up using the wrong model to predict the right stuff and end up having wrong results. Okay, so I at this point I give up. I'll leave it for you guys to maybe go and do some research around it and see how you can work on it. So the last one we have here is this the last? Oh, we have two more. Time is already exhausted. See, this first is annoying. Really, really annoying because it's very annoying. The million you're allowing the model. Which of them is it the rest? The rest that has given us stuff. I hope that's not the one you are liking. Okay, so we have the VGG car. Okay, let's go and get a car quickly. It's really, really annoying the good results. So let's see what the VGG model can do. Oh, sorry. What's going on? Okay. Ah, I'm gonna look for Ferrari. Ah, lovers of Ferrari. Let's see what the VGG can do. Model that works for well for satellite images. I mean, we can actually. I'm not sure. We can actually search for that. Ferrari. Let me go and bring that into my drive. Yeah, yeah. Documentation will help actually. Don't mind me. Just not like we can actually use it. It's just going to involve research, right? So just pick up the model, go and look at how it's built, what was used to train it. That way, it will narrow down to what it can classify accurately. So, um, okay, yeah, we want to look at VGG. So let's see if it's going to classify it as a car or as a Ferrari car. And already there is a link. I think there's a link to, okay, it didn't come out as others. Okay, it didn't come out as others. For this VGG, there's actually a link to where it's downloading the data from. Whoa, mosquito net. Hey, wahala. Mosquito net. Interesting. Are you guys seeing this? Don't go and use this in the medical industry. Oh. Don't go and use this in the medical industry. Oh. Before you guys say somebody is suffering from cancer. Yeah, so it's actually nice we are saying that it's not just about bringing in the model and start making use of it. Some models are specifically used and trained on some data, and it's not just anything you can use it to predict. So that's Ferrari. Let's use it on another model. Let's go back to that mobile net. Yeah, let's go back to mobile net. I'm going to duplicate this. Control A, Control C. Okay, no, I'll just pass it in here. Control A, Control C, Control V. Then I'm going to go back and execute for mobile net. I'm going to execute this. I have to make the model mobile net because it's going to take in the last model I loaded, which was the VGG. Then I'm going to come down here. And I'm going to change this to the link to the Ferrari car. I've done that. Yeah, I'm going to run this. So the model is going to be picking, it's going to pick the model we just run up above. So let me run this. Let's see what image mobile net will do for us. I think it will be accurate. Yeah, 98%. Whoa. So yeah, it's 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 very high. I mean, this is sport car, right? So I think what we've actually learned in a way is that not all models are used for anything. So those two that are actually not predicting what we tried it on, what you can actually do is to just go and do it. You can use it to predict. So from that way you now do know where you can apply it, right? So yeah, that's real intro today. Does anyone have any question for me? Any question? Yeah, I'm going to just share the notebook across. So this is the model. This one is for I think we just need to look for a paper that explains it well. Do you have an idea? No, not at the moment. But yeah, it's something you can actually look online to maybe see if there is an image, sorry, a model that can work for that. Okay, I will not have time to go through this, but yeah, this is just what you have to do for that VGG. Just look for a paper that explains it better. It's painfully slow to train. Blah 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 blah. I'm going to take the notebook now so that we can end it with saying so quickly that I think I'm not sure about this slide, but the notebook is possible. Oh, already Please, I'm coming on. Let me get you the link. Oh my God. Check it. Okay. Uh, Please, I'm coming on. The network is trying to misbehave now. Oh, well. Oh, okay, I'm dropping the link now. Sorry for the delay. Yeah, I've dropped the link. Yeah, I've dropped the link. So just take that off in the next few minutes before we end the meeting. Okay, so yeah, today is the last day. It was actually nice meeting everyone. Though I've not seen your faces, but I'm familiar with some names, and it was nice seeing you guys from the beginning to the end. And yeah, it's been a long ride, so just see how you can work on what you've learned and improve on them and start building your own models. All right, so yeah, that's it. Bye, everyone. Yeah, thank you too. Bye. Let's see, are you there?
Yes,
Hello.
yes.